In this problem from 7.4, number 36, we are asked to solve the equation 9 times sine to the power sine x theta squared minus 1 o equals 0. And if you notice, you can factor out this into the difference of squares, which would give you 3 sine theta plus 1 times 3 sine theta minus 1 equals 0. Now we set both equations equal to 0. First, let's start off with 3 sine theta plus 1 equals 0. First, we have to subtract 1 from both sides, giving us 3 sine theta equals negative 1. Then we divide the 3 to give us negative 1/3, and then we have to get theta on its own, so we take the inverse of sine, so it would be sine inverse of negative 1/3, and theta is actually 199.4712 degrees. And given the conditions, we have to find the reference angle of that, and being that 199.4712 is actually in quadrant 3, we have to find another angle which gives it where sine is also negative, and we find out that that angle is 340.5288 degrees. And now we solve for the other equation, which is 3 sine theta minus 1 equals 0. We add 1 to both sides, giving us 3 sine theta equals 1. Then we divide by 3, giving us sine theta equals 1/3. And then we take the inverse of sine, giving us sine inverse of 1/3, where theta is 19.4712 degrees, meaning that our angle is actually in quadrant 1. And now we have to find the reference angle where sine would fit the conditions as well, where it would remain positive, and that's quadrant 2. So we have to subtract 180 by that angle to give us 160.5288 degrees. But we're not done, as we have to find out every single answer to all of the possible thetas. And since in a sine curve you repeat certain values, you actually have to put 19.712 degrees plus 360 degrees K, giving you all of possible solutions for that certain angle. And then you do the same for the rest of the angles, which would be 160.5288 degrees plus 360 degrees K, and 199.4712 degrees plus 360 degrees K, and lastly 340.5288 degrees plus 360 degrees K.